Here's part two of absolute value inequalities. In this video, we're going to translate absolute value inequalities that are opposite positive numbers to compound inequalities that we already know how to solve. We're going to solve those and write the solutions on the number line and in the interval notation.
3 times the absolute value of 5x minus 2 is less than 24. Our first goal is always to get the absolute value expression alone on one side. So I'm going to divide both sides by 3. Now my inequality is absolute value of 5x minus 2 is less than 8. Remember that one meaning of absolute value is the distance from 0 on the number line, regardless of sign. So if the absolute value of an expression is less than 8, it's less than 8 units away from 0 on the number line, either to the right or to the left. So now we have an interval on the number line that represents possible solutions not for what x equals, but for what 5x minus 2 might equal. That allows us to translate that absolute value inequality to a compound inequality that we already know how to solve. I want to get x alone in the middle, so I add 2 to all 3 sides of the inequality, and that gives me negative 6 is less than 5x is less than 10. I keep going to get x alone, so I'm going to divide by 5, again on all 3 sides, and I end up with negative 6/5 is less than x is less than 10 divided by 5, which is 2. That between inequality represents solutions for x, so I'm going to shade that in red. Negative 6/5 is a little less than negative 1. Here's 2. These solutions in red are what x is. X is equal to this interval between negative 6/5 and 2, but not including the endpoints. When we found an interval with solutions for x, but let's just check one or two to make sure that we have the right thing. So we're going to pick any number in the interval negative 6/5 to 2. I'm going to pick the number 1, and I'm going to plop it right into that original inequality. So I'm checking to see if 3 times the absolute value of 5 times 1 minus 2 is less than 24. Well, that's 3 times the absolute value of 5 minus 2. And that's 3 times the absolute value of 3. And so that's 3 times 3. 9 is less than 24, and so the number 1 that's in the interval checked out. Let's try a number outside the interval. How about negative 10? Well, I put negative 10 in for x, and then I have 3 times the absolute value of negative 50 minus 2 is less than 24. So 3 times the absolute value of negative 52 is less than 24. So 3 times 52 is less than 24. I don't think so. That's 156. And it is not less than 24. So numbers outside the interval don't work. Numbers inside the interval do work to make the inequality true. The absolute value of 2w minus 8 is greater than 4. So let's analyze what this means. If the absolute value of 2w minus 8 is greater than 4, it's more than 4 units away from 0, either to the right or to the left. That means that the expression inside the absolute value, 2w minus 8, is either less than negative 4, or that expression, 2w minus 8, is greater than positive 4. So we've translated our absolute value inequality into a compound inequality joined with OR, and we know how to solve that. 2w minus 8 is less than negative 4. We add 8. We get 2w is less than 4. Divide by 2. And w is less than 2. For the other interval, we have 2w minus 8 is greater than 4. We add 8. So 2w is greater than 12. Divide by 2. And w is greater than 6. Now the OR just carries on here, so let's put these two inequalities on the number line. Either w is less than 2 or w is greater than 6. To write those intervals, the one on the left is from minus infinity to 2, and the one on the right is from 6 to infinity. Now, we're not looking at the overlap between the blue and the red here. Red is solutions for w. The blue is the translation from the absolute value inequality to a compound inequality. So in these last couple of problems, we've seen that if we begin with an absolute value inequality where the number on the opposite side is not negative, it's positive or 0, then we're going to translate to a compound inequality, either a between inequality for a less than or for a greater than to an OR inequality. Once you've translated to a compound inequality, you can just go ahead and solve in the same way that we did the compound inequalities earlier.